I need to put an elephant in Docker. I have a requirement. I'm working on a project, so I need to install PostgreSQL version 19. It's currently in beta. It's available from a repository from the Postgres Global Data Group. In this video, I'll be installing Postgres 19 in Docker. This video is more like a video note for reference. Once version 19 is released, there simply will be fewer steps to have Postgres installed. Up next, installing Ubuntu into the rabbit hole. I'm now in Docker and I'm at the terminal, and I'm issuing a command to start a container with Ubuntu loaded and in interactive mode, basically at the bash. The command tells Docker to reach out on Docker Hub, pull the Ubuntu image, the latest version of it, and create a container called postgresql-19_install. Run the container and place me at the terminal, the bash. Ubuntu is now installed and running inside the container. My next step is to update the package list and then upgrade the packages. The version of Ubuntu inside the container is stripped down. I need to install basic packages just to get some work done. I'll install a text editor, Nano. I'll install superuserdo, sudo. I'll install wget, GPG, and curl. I jumped at the prompt on this one. I'll make it easy for me, future me, by putting the commands in the description. I'm joking. I'll make it easier for you. The commands are in the description. Things are now getting interesting. I'll be fetching and storing the PostgreSQL sign-in key. I'll be using curl to do this. I'll pass some options to curl. F, S, capital S, and capital L. F means fail silently. S means silent or suppress the progress meter so it doesn't show what it's doing. -S means show error. This is the uppercase S. It does not show the actual message but tells that an error occurred. -L, which is uppercase L, means follow redirects in case the URL that I'm specifying leads elsewhere. Next thing I do is I specify the URL for the key. Then I pipe this in or pass it to another command line tool. This tool is GPG, and what it does, it takes the format of the key and places it in the raw binary format. Next thing I use is the T command. Before I had to use sudo. Sudo or superuserdo, basically the root, is the context in which T is being executed, and hence I avoid the permission error because the file is owned by root. There is one last thing. You have a greater than /dev/null. Basically, what T would do is redirect the output to the terminal, kind of like a T junction, right? So with greater than /dev/null, that output is just discarded. It just doesn't go anywhere. So you don't get a screen filled with gibberish, the raw binary format. Things are now getting interesting. I'll be installing postgresql-common. It's a group of programs which manage a database cluster. It also has some helper scripts. For example, PostgreSQL control cluster, PG_CTL cluster. To install Postgres, I'll be using Ubuntu's apt command. However, I need to set up the official PostgreSQL Global Development Group repo, which is where the binaries are, as a source for Ubuntu's apt. To do that, I'm going to use a helper script from postgresql-common. And that's why I needed the key from earlier to ensure that the Postgres repo is legitimate. The Postgres repository, as currently configured, only exposes released versions of Postgre. I now need the beta version, which is version 19. I need to update the source file so that it will know where to look for version 19. It's simply in another directory and not the main directory. The source file indicates the main directory. I'll add 19 as a source directory as well. Now I need to update apt to confirm that PostgreSQL 19 is now visible and is an installable package. Next, I will go ahead and execute the command to install PostgreSQL 19, which is sudo apt advanced package tool install PostgreSQL-19. I'll explain said stream editor in the description. Postgre has been installed and the post install script wants to start the service. However, it doesn't call system control to do so. Instead, it uses a wrapper script. This script is called invoke-rc.d. However, the script will not be able to start Postgre, and that's because it's in a container. Containers deny unconditionally all service starts. Postgre will have to be started manually for this first time. To do that, we execute the pg_ctl cluster command. Next, I'll list the clusters to make sure that it is running via a status of online. At this point, Postgre is installed in the container. However, it's not any good if we cannot connect to Postgre from outside the container. To do that, we'll set up a password for the Postgre role first. Then, I'll edit the postgresql.conf, that's a config file, to tell Postgre to listen on all interfaces. Then, I'll edit the postgre_hba.conf file. Basically, this is like a firewall file for Postgre. I'll tell it to accept connections coming from the host. Now, once this is done, I'll have to restart the cluster so that the changes are confirmed. And then at this point, I'll be able to connect to Postgre from outside of the container. Sometimes it's PostgreSQL, sometimes it's Postgres, sometimes it's Postgre. What fun! When the container runs, Postgre will not start on its own. So I'm going to create a startup script which will start Postgre when the container runs. I'll be using the same command we saw before, pg_ctl cluster, to start the container. Now I'll have another command in the script called tail. If something goes wrong and Postgre doesn't run, the container will not really know. It will just continue on. So the tail command will output some information into a log file so that you can see whether the container is running properly or not from Docker side. I'll also need to make the script file start-postgre.sh executable. So I'll be using a chmod command for that, and I added +x to make it executable. Then, once this is done, since all this time I was working in Docker, I was working interactively, I need to commit the changes that I've made to the script. Well, a correction there, to the image. So anytime I spin up a container from the image, it will launch Postgre. And I can spin up as many of these as I like, which is absolutely fantastic. So that part is very important. Commit the progress that we've made in Docker. Now I'll use the docker run command to spin up an instance of Postgre which is in our container. Some notes on the command. -d means detach mode, so it runs a container in the background. -p, what this does is maps the internal port, which is being used in the container by Postgre 5432, to an external port of the same number. So the right side is the port Postgre is actually listening on, and the left side is the port which is exposed to my local host. There are some other concerns. Memory is 1, --shm size, shared memory size is 256. So basically I bumped up the size of the shared memory of the Docker container so that let me start it again. I increased the size of the shared memory in the container from 64, which is a Docker default, to 256. Now Postgre, based upon the install, use shared buffers of at least 128 megabyte. So it would literally crash. Entry point, the script that we created earlier, is the entry point, so it will start Postgre for us. And that's it. The version 19, the beta is now installed and running, so now we can connect to it. I'm now in pgadmin 4, which I'll be using to connect to the Postgre instance running in the Docker container. So in summary, I used the latest version of the Ubuntu image to create a container. Once inside that container, I interactively made several commands to update the advanced package tool repository, upgrade the packages therein, install several helper utilities, nano, sudo, wget, gpg, curl, etc. I use curl to download the key from Postgre. Then I install postgresql-common. postgresql-common, which is some helper utilities and scripts. I then use the sed command to update the Postgre repository file, which was provided by the Postgre Global Development Group. And then I updated the entire system, installed Postgre 19, and now I made some configurations so it would start automatically in the Docker container, in addition to accepting connections from the network from outside the Docker container. And here we are. Thank you. Hope you enjoyed it. And I am your principal DBA.